So last time we were reading stuff in from a file and looking at parsing a string. We'll look at that some more today. But so the homework assignment was to finish filling out our maps.txt with the rest of our exits, and then read in rooms and exits into two array lists. So let's go ahead and do that. I think we have a couple of our exits already put in there. That is different thing. All right, so for our exits, we already have the esports west. So we have this guy. So now we need to do a lobby network. So lobby to the west, network to the east. West, network east. Then we have lobby north, hall 0 south. Then we have S120 west, hall 0 east. And hopefully we're spelling everything right. Then we have hall 0 west, hall 1 east. Then we have hall 1 north, entrance south. Make sure I spelled entrance, yep. Then I have hall 1 west, hall 2 east. Then I have hall 2 west, hall 3 east. Then I have hall 3 south, S118B north. Spell it up here, capital B. Hall 3 west, lab 1 east. Hall 3 north, soda room south. Soda room west, lab 2 east. So I can put a space like that. Oh. All right, and do we see any obvious spelling errors or anything in there? We'll find out soon enough. Go with it for right now. All right, so now we have all of our stuff in there, and the state we left our code in last time was we were reading in from the file and we went ahead and just proved we were reading in the room. So if we're looking at rooms, we're going to change our mode to rooms. If we're looking at exits, we'll change the room to exits. Otherwise, we must be reading in information regarding whatever mode I'm currently in. I'm either reading rooms in or I'm reading exits in. So if the mode was exits, I'll go ahead and say I'm building an exit. I'll show the line we read in. I'm going to then use my function we wrote, parse exits, to give me the 4 pieces of information that make up an exit. And then I'm going to show what those 4 pieces of information are. And before I did exits, like I said, if the current mode was rooms, I'll just print out the name of the room. We're getting 1 piece of information about a room. So we'll go ahead and run this here. All right, so here is the names of all my rooms. We actually have to build those rooms. We haven't done that yet. And then here are all of my exits with the individual pieces parsed out. So I have the 4 pieces of information. All right, so let's start by building objects for all our rooms. We're going to create, I think the assignment, create 2 array lists, right? An array list of rooms and an array list of exits. But the exits part that's the part that was probably going to be a little more difficult. All right, so let's start off with our array list of rooms. So I'll come up here and I'll create an array list of room objects. Call this guy the rooms, and it's going to be a new array list of room objects. And I'll go ahead and create my array list for exits because we're going to be filling that here. So I'll say array list exit. Call this guy the exits. This is a new array list of exits. All right, so now we have empty containers, empty array lists ready to be filled up with rooms and things like that. Now, as a reminder here, here's our rooms. To build a room, we just need its name. Pretty easy to build rooms in our case here, right? We're reading in a name, we have the name, build a room, put it in the array list. So here's the room we were just reading in. So I'm going to say the rooms dot add a new room built with the name we just read in. Explain the hell you went through based on the response. Well, that's good. That's the point of it. Even though line is the name? Yeah, because yeah, you got like this guy right here. Right, but they actually call it, display. Oh, well, we'll get to the exit side of things in a second, but just building the room. Oh, I mean, it worked. I got you. So you made it way harder than this. Way hard. Like, you'll take a look at it like, wow, that's like okay. All right. So yeah. So in this case, we read in. This is the value of line, for example, right there. Right. That is the name of a room. We need a name of a room to build a room object. So what did I do? I used that, and if you wanted to, you could have said something like room temp is equal to new room line like that, and then add temp here. Yeah, some folks like to put it in a variable first and then add it. The only reason, I mean, I would say that this is probably not the best programming practice because typically you're going to create a variable whenever you need to use the value more than once, right? And in this case, I only need this room stored one time because after that, it's just going to be located in some bucket of my array list. Not that this is incorrect. This is saying the same thing. The value of temp will be the result of new room line. So nothing prevents me from just saying, look, I'm just going to build a room right there. Make sense? All right, but you can pick your poison. If you want to put it in a variable and then put the variable into the array list, you're not hurting much. All right, so whenever we run into a room, we get the name of the room, which is stored in that variable called line. But then we'll just go ahead and build an actual room object using that name, and we'll put it into our array list. All right, now we purposely have our file set up where we read in all of our rooms first, right? So presumably we've already filled up that array list with instances of rooms before we ever get to our exits. All right, and just as a quick example based on one of the questions I had, I'm just going to go here into when we see the line that we just read in as exits, we know that all the rooms have already been created at this point. I'm just going to go ahead and write a little loop. I is less than the rooms dot size, I plus plus, and I'll just do like a system dot out dot println the rooms dot get I. Okay, let me make sure I don't have a toString in here, do I? Because I don't want one in this case. Okay, good. All right, so I'm going to go through every bucket of my array list called the rooms, and I'm going to print out the value found at a particular index in that array list. The kind of animal that guy is an instance of a room object. So I'm going to see a memory address here. All right, so when I switch over to the exits mode, I'm going to prove to myself that I just built whatever it is, 13, 14, 15 room objects. So I should see a bunch of unique memory addresses. So here's my memory addresses for all the rooms that I built. I built the rooms, I threw them into my array list for rooms for us to have to deal with them shortly when we deal with exits. Presumably the difficult part here. I think I gave you a hint though on the homework, right? Yeah. Okay, so I got a big collection of room objects now. All right, so now here, I'll wrap that in a comment. And let me go ahead and just take some of this extra fluff out of here so we have a little bit less stuff being spit out by our code. Yeah, this is fine. Okay, so I'm not printing anything out now. So it runs. Oh, I am still printing out build room somewhere. And then just at the very end, I'm saying my map is built. All right, my about to parse is down in my function down here. Here's I'm about to parse something. Just turning off a bunch of the commentary so our screen isn't just filled up with a whole bunch of stuff. All right, so at this point, we now have our array list filled up with, called the rooms, filled up with room objects. Next thing that's gonna happen is I'm gonna deal with exits. So if I'm in the exit mode, I'm reading in lines that look like this. And we wrote a function last time where we can pass a line that looks like that too. And it gives me back a string array with 4 elements in it. Bucket 0 will be this string, bucket 1 will be this string, bucket 2, bucket 3. All right, so now we need to go and look at, and our goal here is to build exit objects and put them into our array list called the exits. What does it take to build an exit object? We look at our constructor for our exit object. We need a room that is one of the destinations. We need a string that is the direction leading to that room. We need another room object that is the other destination, and the string leading in that direction. Right now, what I have is I have 2 room names and 2 room directions. I need to somehow turn those room names into the actual rooms that are associated with a room with that name. So I need to write some sort of function that's going to go through and say, hey, here is the name of the room I have, S118B. Can you go through and search and find me the actual room that has that name? Make sense? So inside of our room here, name is a private variable. So we can write the ability to get the name from this guy if we want. So we can say, here's a public function that returns a string called get name, and this returns this dot name. So I gave the ability to our room class to give me the name of a room if I asked for it. And we had to do that because this variable is private, which means it's only accessible inside of the room class. And I'm going to be trying to access it inside of main. All right, so we're going to write another function down here. All right, so this function is going to be private static. It's going to return a room. And we're going to maybe call this guy get room given name. So we're going to pass this guy the name of a room, and it's going to search through our array list of rooms, finding an array list that has, or finding a room that has the name that was passed in. Now, right now, my array list is inside of main here. So its scope lives and dies with main. So if I want my function to have access to this guy right now without making it more global, let's say, I'm going to say, I'm going to pass it as a parameter, the array list in which I want it to look. Here's the room name. Here's the thing I want you to look in. Go and find it. All right. And I didn't have to put this in a function, but let's separate it out a little bit. Now we wrote the ability into our program to say, hey, here's a name. Give me the room associated with it. And then we can just call that ability of our class here. So we're going to go ahead and we're going to loop through all the possible rooms we could be dealing with here. So stock for loop for int I is equal to 0. I is less than the rooms dot size. I plus plus. So this loop will take I on a voyage through all the indexes in my array list. So to get the actual room that lives at a particular array list, I'm going to say the rooms dot get bucket I. This guy right here will boil down to a room object, an instance of room. I can then ask that room to give me his name, which is going to be a string. The room class has a method now called getName that returns the string that is the name of that room. Okay. So this guy right here will be the name of the room as a string. And I want to say if the name of this room as a string dot equals the room name you gave me. If I found a match, go ahead and return the rooms dot get I. Now we could, just as the antithesis to what I said a few minutes ago, we could make the argument in this case that, well, I'm using the rooms get I here and I'm using it again here. So we could make the argument that maybe we have a room variable called temp. We set temp equal to the current room. Then we ask, does temp's name equal the room name? If so, return temp. Following that argument that when do we create a variable to hold something? When we need to use it more than one time. In this case, I happen to be using it twice. But logically, this is going to do the same thing. So I'm going to go through potentially every single room inside my array list. I'll grab the current room we're looking at. I'm going to ask a question. Is the current room's name equal to the name I'm looking for? If it is, return that room. And remember, return makes a function immediately end. So it's not going to go through this loop any more times or anything like that. Now, if I ran this code right now, Java's going to scream at me. It's going to say, look, you told me you're returning a room. But I don't know that you are going inside of that. I don't know that we, as a human being, we know that we will get to this return statement in here. Java's not convinced of that. It's entirely possible that we will never get inside this if statement. So that means it's possible that this code doesn't return a value. So we could do something like return null. But I would actually say a better thing to put here that's going to help us find possible typos more easily, because return null is going to give a null value back to whoever called this, that we might say, oh, well, you gave me nothing, but I'm going to pretend like this is a room and start trying to do room stuff with it. And I'm going to be calling methods on nothingness, and it's not going to be happy. So instead, we probably want to have some sort of error message that pops up. All right. So in a situation like this, where Java is going to say, look, you have to return a value. You have to return a value. We can do something called a runtime exception. And we can give it a message. We'll see this here in a second. Let's see, that guy is in Java.line. We already have them. Just constructors. It doesn't. Okay. So rather than return something here, we're going to say throw new runtime exception, room with name, room name, not found. All right, so this function now throws an exception, specifically a runtime exception. And what's nice about something called a runtime exception is that you don't have to do a try and catch somewhere else in your code. It's you optionally have to deal with it. But at least from a programmer's perspective, we will see a nice, pretty error message up on the screen saying, look, you tried to have me find this room with this name, and I couldn't find it, which probably indicates to us that we have a capitalization or a spelling error somewhere in our stuff. That'll help us zero in on it pretty quickly. But it also said that we didn't have to return a value here because we specifically said, Java, I know that if I get to here, something's gone wrong. And I'm going to scream about it before you have to scream at me. All right, so now we have this ability, get room given name, that I can toss a name to, and then my collection of names, and it should give me that room back. All right, and my parts that I'm getting back from exit parts is bucket 0 is going to be is one of my rooms. Bucket 2 is going to be my other room. Right, so I need to get those 2 rooms. So if I'm inside of exit here, I'll go ahead and say room dest1 is equal to main dot get room given name. The name is exit parts at bucket 0. That's the name of my room as a string. And I want to search for this inside of my array list called rooms. Get room given name is the function we just wrote. I'm passing it a string and an array list of rooms. That's what that guy expects from me, a string and an array list of rooms. And he's going to spit out the room, the actual room object that has that name. Or we're going to get a nice error message on the screen saying, you know, bad news bears, you know, it's we didn't find it. And we'll go ahead and say string dest1 is equal to exit parts at bucket 1. Room dest2 is equal to main dot get room given name exit parts at bucket 2 and the room. So we'll go and look up the other room string, and this is not going to be we'll call that guy we'll call this dir1. dir2 is exit parts at bucket 3. All right, so now presumably I actually have the values that I actually need to build an exit now. I have 2 rooms, 2 strings. That's what an exit takes. A room, a string, another room, and a string. So I'm going to go ahead and add this exit to my list of exits. The exits dot add, and I add a new exit here, and I'm going to add an exit that is dest1 dir1 dest2 dir2. The 4 pieces of information that I needed to build an exit after I did the map lookup of here's my room name. I need the actual room that has that name. All right, then if we want to see that we built some exits there, we'll go ahead and just write a for loop down here after we've gone and done everything. So in I is equal to 0, I is less than the exits dot size, I plus plus, and we'll say system dot out dot println the exits dot get I. We should have a whole bunch of unique memory addresses for exits. So we'll see here if we had any spelling errors in our map. I'm missing an extra parenthesis right here. Okay, looks like we did not have spelling errors. So all of our room names matched up to what we wrote for our exits. So there's all my addresses for my exits I built. Okay, so presumably the map is built. So that would be acceptable for the homework assignment, even though we really haven't tested what was built there. We can go in here. What did I teach exits to do at this point? And exits, Well, displaying themselves isn't really going to help much. Let's just put ourselves into the map now and to test it that way. All right, so we know that our entrance is where we plan on starting the game, if you will, okay? So out here in main, we've now done all this stuff. What I would probably do is this. I'd probably write a function, private static build map. And I'd pass this guy my two array lists. So my array list of room objects, all the rooms, and my array list of exit objects called the exits. And then I would come up here and I would take all of this logic that we just built. Get rid of all of it right now. And I'd plop it in there. Get rid of some of these comments. So now I have this thing called build map. I just have to throw my two array list at it. Main dot build map, pass it the rooms, pass it the exits, and it'll build my map. So that makes main look a whole lot less messy, even though the same crap is here. we just hit it down here in this function that we never have to look at again, unless we need to make a tweak. Oh, I don't have a return type. Sort of on purpose, actually. So I'm not going to return anything from this guy, but I'm going to ask you in a second, why do I not have to return anything from it? Remember, we had this throw exception thing. We talked about how you can do a try catch yourself, or you can throw the exception. Well, here will be an example where, since the exception can happen right here, if I'm going to be lazy and just throw the exception here, the person who called this function is going to get that exception. So then he has to throw it if he wants to keep passing the buck. All right, so my map is now built, but the question I have here is I passed in these two array lists, and let me just kind of prove it with this last part here. I'm going to get rid of the for loop from inside of that function there. And I'm going to put it back here in main. So in main, this is where I defined my two array lists. I passed those two array lists into build map. Build map then does its magic, but build map does not return a value. Yet we're going to see out here in main, exits, the exits has stuff in it. Why is that? Why did this array list get filled up with the values, even though build map didn't actually return my array list after I added stuff to it? Why did we not have to return a value there? This gets back to our concept of pass by value versus pass by address. An array list is an object, right? It's an object type. So if I were to print out the value of the exits right here, I'd get a memory address. So there's the value of the exits. And I'll go ahead and print out the value of the exits right here. So this is the value of the exits from that scope. This is the value of the exits from that scope. And we're going to see that they are the same memory address. Oh, of course, it puts it in a, it just shows you the empty list. They wrote a toString for that. I don't think I can force it to give me the parents version of that. Well, they look identical, but that's just showing what an empty array should look like. I don't know if I can get the actual address of that array list. So let's just go with this. Trust me that the memory address there is the same identical memory address as is right there. So any changes I make to the exits in here happen up in memory where it's pointing to. So in here, I have that change. Go ahead. Well, I made it void because I'm not planning on returning a value. I don't need to return a value because the purpose of build map is to fill these two guys up with stuff. And because I already have access to those two guys in the place that I called this from, I don't need to return the answer to them. They're going to already get the answer. They're going to have it. They're still holding on to the buckets while this other thing is filling them up with stuff. Make sense? Okay. So now I built my map. Next thing we'd probably want to do is put a player in there. We already built player. Well, we already created the ability for having a player. So here's a player. Player's going to have a name. And we're going to set their current room to nothing initially. So we're going to go ahead and say player. We'll call him the player. Equals new player. All right. So now the player exists, and they're just sitting over here to the side. The map exists. Now we need to put the player into the entrance of the map. So let's get the entrance. So we're going to say room, the entrance, is equal to main dot, what do I call it? Get room given name. So I'm going to go ahead and ask that function to get me the room given the name. Now, get room given name, that guy requires that I pass it an array list as well as the room name. I'm going to pass him the rooms. So I'm going to ask this function to find me the room in this collection of rooms that has this name. Why? Because that's the name of the entrance to our dungeon. That's the room I ultimately want to put my player initially in. So for room, we need to have the ability to add a player. We have it right here, add player. And that sets the room's current player to that guy. A player also knows about their current room. So we're going to go ahead and have a function inside of player called set room. That's going to take a room in and set that player's room equal to the room that was passed in. Both of those things need to happen. When I add a player to the room, I also need to remember that the room I'm in is the room that I just got added to. So two things know about that relationship. The room knows about me, I know about the room. So what we'll go ahead and do is when we add a player to the room, we will also go ahead and have the room set the room to himself for that player. All right, so a room knows how to display himself now. So I'm going to go ahead and say the entrance dot add player, the player, and I'll go ahead and inside of player, let's just write a quick function, public void look around. That just asks the current room to display itself. So if the player looks around, they ask the current room they're in to go ahead and display itself, and I should be in the entrance. The player dot look around. So I'm in the room, the entrance. There's me there. Now, obvious exits. I don't see an exit going from our entrance in our map here to the north to our hall. So I should have entrance to the south, hall 1 to the north. Was that in our map? Entrance is the south. Hall 1 is to the north, but that's not listed as one of the exits. Why is that not listed as one of the exits? Well, I'll take a peek at that and make sure I give you working code. But your homework, I don't remember. Did we not? That would make a lot of sense if I didn't do that. Here, I built my exit. Oh, I added it. Oh, yeah. I never actually told the I built my 2 array list, but I didn't actually tell the rooms that, hey, here's your exits. That's a good point. Okay. So actually that actually makes a good a better next step assignment than what I was going to give you. Probably a little easier than the one I was going to give you. So homework. So I'll go ahead and save this. Share the current code. So given this guy, now that we have both array lists built, write the necessary code to add the exits to the appropriate rooms. And this, once you think through this, this is actually not going to be hard. So submit a link to the code and a self. All right, questions about what I'm asking you to do? Because once you do that, your test case will be, when you run this, it'll show that the obvious exit is to the north in here. All right. I will see everybody on Monday.